Alright, hey everyone, welcome back. We have another USAMO number 6 from 1998, where n is a given integer, and you want to find the maximum number of circumscribed quadrilaterals that you can get using vertices from these k guys. Sorry, from the n vertices. So, let's see. N equals 4, like 1. So n equals 5. I guess the question is, like, is there an obstruction to... You have a general... pentagon? So I guess the question is there a reason why I think that it's not possible for all of them to be circumscribed? And I definitely have to use like the convexity or whatever. So a quadrilateral, by Python's theorem, a quadrilateral is circumscribed if and only if the opposite sides add to the same thing. And so here I have 10 blue segments drawn. If it was actually the case that all the blue segments were equal length, then all 5 quadrilaterals would be okay. That's definitely not what's happening, because like you can't make a convex quadrilateral in 3D space with that property. Like an equilateral pentagon will never have yeah, equilateral pentagon will never have that property. But why? Thank you, Nuke Launcher, for the cheer. Happy New Year to you as well. Thank you, Dotted. I have to use convex somehow, actually. Okay, well, let me think a little. If I have a pentagon, how many can I get? I mean, I can definitely get 2. I can probably get 3, honestly, if I make things symmetric enough. Or maybe not. Isosceles trapezoids are not necessarily circumscribed. Like, it's not how many cyclic quads can you get, it's how many inscribed can you get. So it is true that all, like, regular polygons actually do okay. If you have a hexagon, every kite is circumscribed. Yeah, regular pentagon gives 0. I agree. But a regular hexagon is okay. A regular hexagon will get 6-ish, I think. Well, okay, here's an estimate actually. If I have two given, so suppose I have this, suppose I have a polygon, it's like some blob. It's convex actually, so I should draw it more convex. And you have two sides, and I want to figure out what the fourth vertex is. The locus of points the fourth vertex could be is given exactly by a hyperbola. So there are at most 2 points that you can use. No, actually, it's signed. At most 1. Is Pentagon 2? I feel like is it that small? Oh, wait, also, I'm not reading the question. Oh man, I did the whole intro and I didn't even read the question correctly. It's asking AI plus 1, AI plus 2, AI plus 3 specifically. So like 4 consecutive vertices. Oh no. I'm solving the wrong problem. So it's 4 consecutive vertices, not just 4 generic. So that changes things. So, okay, let's look at the pentagon again. Actually, for pentagon, it doesn't change anything, but for everything else, it changes things. So 3VT said something about sharing a side not being very good. Sharing two adjacent sides? Why not? I don't see why n equals 5 had to be k equals 1. In fact, or k equals 2. Like, you're claiming that this shape that I've drawn never occurs, but I don't see why that's so. It would be nice if it was true, but I don't see why. Didn't you say hyperbola or something? I was trying to do something different where I was like given to. Oh, actually, no, you're right. There's a the locus of points for which the difference is equal is like some hyperbola branch. And a hyperbola branch won't intersect. Oh, I did have this. Yeah. Hyperbolas should intersect a convex polygon in at most one vertex. Is that true? I feel like that requires some justification. It's not quite a hyperbola. It's contained in a branch of a hyperbola. So the point is, like, given two vertices, you look at the locus of points for which, like, this minus this is like a fixed constant. This is given by a hyperbola. That looks like that. And the other branch, but we don't care about the other branch. And I wanna show that I can't have like three vertices. I wanna show if I have like three vertices on this branch, then it's not convex or something like that. I think that's just true because if I have 3 points on a hyperbola, something bad happens. Oh, but these are supposed to be consecutive sides, so like everything should be on one half of the line. So like this is getting very abstract. I don't know what the answer yet is, but I suspect it's like about half of them. Is my guess based on this fact that I think it's very unlikely that you can have Yeah, I think this shouldn't happen, but I can't prove it. Maybe I can though. Like, I should just draw a hyperbola and think some more about it. Maybe it can happen if I distort this picture enough. Like, is this like, I guess that's a pentagon. Sort of. Can... Oh shit, I'm not scrolled. Is that a convex pentagon? Is... I... Thank you, Dotted, for 1 bit cheer. We'll get to the tournament, that's fine. Haven't you already proved 4n over 2? Well, I mean, if you look on the board, there is a picture that looks plausibly like a pentagon for which the 2 quadrilaterals share adjacent sides. So, like, I don't know. I didn't get any equation. I'm using the definition of a hyperbola as like a locus. This should obviously not work. I don't think it's obvious. I mean, does this picture look that wrong? Okay, you know what? There's a way to settle this. Let's settle this. Oh yeah, actually that looks pretty bad. If D is on the hyperbola, then the whole hyperbola is contained in angle IADC. Why is that true? This is like just true. I mean, probably, but like, why? I do agree. I when I drew the thing on the Miro, I got the impression it was probably actually true, or might not be true. But now that it's in GeoGebra and the diagram is perfect, I agree. I agree it should be true, but I don't see how you prove it. Like, I agree that. Like asymptote stuff. You're really not helping here. Well, I mean, of course it's true. Okay, I don't know. Maybe one way we can try to give a airtight proof is to look at this ray DE. Like, in a convex quadrilateral, they can't intersect AB. The tangent to the hyperbola is there, and it hits B, and then like... If you said what 3PT said without any further reasoning, like, probably. Like, of course we know it's true. Like, here, the Riemann hypothesis is definitely true as well. But, like, no, like, you have to actually prove things. Like, you can't just say they're obvious when, like, there's something to prove. 529. If the proof was easy, then you can not say it. But if the proof is not easy and you don't state the proof, then, like, I don't know, what do you expect? Thank you, 5 for the 2020 for the follow. It's clear that segment dx of hyperbola lies on one side of CD, yes? Wait, what is that? Let's be the apex of hyperbola. I mean, I think the argument is probably something like here. Honestly, the tangent argument might be easiest. Like, so you consider the tangent. I think as I vary E, there's a bijection between like points on the hyperbola and let's say like the line A. AC is probably easiest. So there's a bijection between like points. Like, if I fix D, there's a bijection between points on the hyperbola, E, and, like, the line AC. And it's continuous except for situations where DE is parallel. That's one place it can be not discontinuous. Or when it's parallel to the asymptotes. I.e. when is it that true? I'm nothing here, but... Well, actually, I think it's just continuous on this branch. If I On this branch, it's a bona fide continuous function. But when d equals b, it will... Why does it not pass through A?
Evan, you should check the chat.
And proof 80 doesn't intersect the right half again. I mean, isn't that literally equivalent to the thing we're at? I mean... '80 intersects the left half once. Let's see. So when you have a hyperbola... Okay. That should be true, yeah. So the hyperbola will cut the plane into 3 regions. A is in the leftmost region, D is on the boundary between the middle region and the right region. Like, or use AC as like an oriented, yeah. Yeah. And... so 80 intersects the hyperbola again. Wait, why does that work? Yeah, I mean, this should be floor and halves for sure. There should be a bound of floor and halves for sure because no two. Let me share a side. Like you can't have them share that many sides, but D. Oh, that is a much better way to do it. So this hyperbola garbage. Yeah, okay, fine. I mean, yeah, that looks like it works. Okay, that means I can close GeoGebra. So claim all possible A1, A2, A3, A4, and A2, A3, A4, A5 are circumscribed. Okay, and if that's just... we've decided that should be true, so there's a bound... there's always a bound of floor and halves. Now the question is, can I achieve the bound? Can you just do greedy? I feel like you just do greedy at this point. Like... Oh, this is really annoying to draw. Ah, undo. No, what the heck? It's just out of battery. God damn it. Why does this always happen? But yeah, I agree that something like this should work. Odd end case should be the easy case, actually, I think. If you could probably, it's honestly probably easiest if you make them cyclic or something. Wait, are isosceles trapezoids ever circumscribed? Like, I'm trying to think, can you just make it an isosceles trapezoid and be done with it? Yeah, I had that thought, but... I agree this works for the odd case. I'm actually worried about the even case because then you also need it to close up exactly. It should be okay, I think. This only works for even. Wait, what? The heck? Wait, how do you know? What the heck? Like for any no, what? You can't do that. What? Like you want a construction that looks like this for some right? And then you want to make it such that one of the isosceles trapezoids is cyclic. I don't know. Are any of them cyclic? I feel like this doesn't work. Take the unit circle. No, what? No, it's not the cyclic. We're trying to get that inscribed. A lot of isosceles trapezoids have inscribed circles. Yeah, but like I need a do I not need like a 60-degree angle or something? Oh, I'm moving the wrong one. I see. Okay, okay, fine. So I fix. I fixed that one and then I moved this length. And then it's okay. Fine. And then if I have like n equals 7 or something, then instead I why can I erase the black guys? What? Okay, so I can. So I fix 3 things here. And then I pick the red vertex here. Wait, what? Hang on. Something's weird. Something feels weird to me. The idea was that we try to vary this length, and then I'm not convinced the monotonicity of these functions is going the right way. Like, I have a guy of fixed length, and the others two. There's like 3 lengths that are varying, right? There's like X, X, like something like this. And this angle is fixed to be 120 degrees. It's like 60 degrees, whatever. You can vary them, and you want like y plus z equals 2x. I am concerned that y plus z seems like it should. There is something to do here, right? Like, it's not just going to work, right? Depends on the length. Okay, okay. When A1, A2, A3, A4 is a square, we overshoot. The heck? You don't need 60 degrees. How do you know it closes then? Oh, if we're not putting them on a circle, like, does the polygon, like, close itself? So it's on a circle. Like, what? Yeah, I mean, some people just don't have patience. Whatever. But here's the problem with what you're saying, okay? Like, if you aren't restraining it to lie on a circle, then you are constructing the sequence of points. In order for a point to have a continuity argument work, you have two parameters that you need to get working out. You're restraining on a circle. Wait, so then what's wrong with this picture I'm drawing? No, I drew it on a circle and you started telling me, like, no, you don't have to worry about the circle. 60 degree is not needed. Oh, yeah, I'm assuming n equals 6 right now. I'm just trying to draw an n equals 6 picture. I mean, it works for the 60-degree angle here because if I make x the full length, then it's like fine. Okay. Do I get the right, so red, I think this should work in general. Ah, frick. No, can you let me, try to do the problem? Like, I had a thing that was going to work, and then you started arguing with me about it until I got so confused I thought it wasn't on a circle anymore, and then you told me, no, it's on a circle. If it's on a circle, this part should be fine. I just need to think about it for a few minutes. Like, I don't know, like... Okay, anyways. If x is here, this... let's see. So x is non-negative. S goes to 0, the sign goes one way. If I push x all the way, then it's like 0 plus 2x is greater than whatever this length is. Dotted. This W. Yeah. Yeah, so then this is fine. What you say is like by triangle inequality, if I push... let me clean this up. Yeah, so this length is always less than 2x by triangle inequality. So you can vary the length of these red segments, and then you'll get the PyTorch exactly at some point, because here, if you let x to 0, this side is clearly larger, because when, like, this... If you let x to 0, this side is smaller. If you let x all the way to this side, then you get this one, the two blue ones, and the long blue one. So this side is clearly larger. Okay, yeah. So that will settle all the even n. And I was trying to say, I just wanted to squeeze in like one more vertex, right? So if I do... Can I not just do this? if I put like one here, one here, one here. So like for example, for n equals 7, right? I need 1, 2, 3, 4, 3, 4, 5, 6, 5, 6, 1, 2. So I actually need the first two vertices to still kind of work or something like that. Jeez, that's so annoying. Yeah, okay. So do you still want to do, is it still going to be a isosceles trapezoid type thing? Yeah, actually something like this should work, right? So you pick this such that these are isosceles trapezoids, and then for the last one, you just take this hyperbola or something. Actually, I think the cleanest thing to do is like inscribe it in like circle with a certain diameter. That way, it's you don't like the hyperbola step becomes a little bit easier. Where 1, 2, 3, 4, 5 can go on the circle. Ah, I missed. Hey, what is help? So we'll take this one and so do shoot. These are isosceles trapezoids that you rig such that you rig these such that they're isosceles trapezoids by before, and if you want one, hang on, what? I need one more, right? I want A5, A6, 1, 2, 3, 4, 3, 4, 5, 6. Oh, come on. Dang it. 1, 2, 4, 6. Let's make 1, 2, 4, 6 fixed. This should be about the same argument. Okay, so you make isosceles trapezoids. Wait, why am I so bad at this? No! Whatever. Okay, we can just have the hyperbola intersect. Yeah. A6. And then I need to make just one more, so make it like 3, 4, 3, 4, 5, 6, 5, 6, 7, 1 or something. And Yeah, if this is a diameter, then there's some chord that I can draw that will have a circle inscribed in it. Again, by continuity, because when I have A7 equals A6, red plus green is larger than blue. But if I have it at A7 equals A1, then the blue part is clearly longer. So then you vary this one as well. Alright, that's fine. Is that right? Yeah, that should be fun. Yep. Opera trip. Okay, so if you don't know what mute me does, then I will refund your points because I'm nice. Mute me means that I mute you for 10 minutes, so you can't talk for those 10 minutes. I don't know why people redeem it, but some people redeem it knowing full well what it does. So I haven't deleted it. Yeah. Yeah. I am a little disappointed by this problem. I'm not gonna lie though. Like, I was expecting something pretty cool, but I feel like nothing that surprising happened. It was just like, the hyperbola statement was just like definitely true. Oh wow, I didn't draw the diagram. Show the diagram. Something. Yeah. Like, I just feel like we just had this hyperbola out there, like, we know it's true, and it's just annoying to prove. Like, we have to prove it, but it's annoying to do so. And then the construction's just like, yeah, like, it's fine, you just gotta construct it. Alright, good night, Carla. Also, I'm very glad I didn't have to write this up. Yeah. I feel like during a contest, this would be super annoying to write up. Thankfully, we have like the nice proof that two consecutive things don't work, like by just continuity and, or not just by length chasing and then citing triangle inequality. But the continuity argument for the pi tot is also super annoying to write up properly, I think. Hardest problem on stream. I've gotten problems on stream that I just outright gave up on because I was like, I'm not getting anywhere and I don't want to waste everyone's time. The longest solved was TSTST 2013-9. That took about 3 hours of stream time. Yeah, Jadon's problem. Yeah, Jadon's problem was just like, no, we're not getting anywhere. I think we're done. But the longest one that we actually solved was TSTST 9.